Hello viewers, in today's class we are going to solve a very conceptual problem in vectors, and the problem is written here. For any vector A, we have to find the value of this expression, right? So let us start. So here we see that this expression has three terms. This is the first one, this is second, and this is third, right? And here we have a vector A, and I cap, j cap, and k cap are the mutually perpendicular unit vectors, right, in the direction of the coordinate axis, right? So if we have the coordinate axis as x, y, and z, then the unit vector along x direction is I cap, along y is j cap, and along z is k cap. Okay, so now we have here a vector A. Now let vector A is given as, say, A1 I cap plus B1 j cap plus C1 k cap, right? So here we assume that the components of the vector A are A1, B1, and C1 along the three coordinate axes. Now here we have the first term, that is vector A cross I cap square, right? Now this expression can be written as the magnitude of A cross I cap square, right? So see, here we have the vector A cross I cap square, and here we have the magnitude of the square of the magnitude of vector A cross I cap. So here we have used the important concept that square of a vector is equal to the square of its magnitude. So we are using this result, that square of a vector is equal to the square of its magnitude. So here vector A cross I cap is a vector, and here we have the square, and here we have the magnitude of vector A cross I cap. Okay, so now let us find out vector A cross I cap. So we have to first find this cross product, right? So what is vector A? So we have vector A as A1 I cap plus B1 j cap plus C1 k cap and cross I cap, right? Okay, so now let us take the cross product of these two vectors. So we have A1 and I cap cross I cap, because we have I cap here, and here also we have I cap, plus B1, and we have j cap cross I cap, and then we have C1 and k cap cross I cap, right? Now from the definition of the cross product of two vectors, we know that if the two vectors are same, then their cross product is a zero vector. So this term is A1 times 0 vector, because I cap cross I cap is 0 vector, and here we have B1, here j cap cross I cap is minus k cap, and here we have k cap cross I cap is j cap, right? Because when we have I cap, j cap, and k cap, then I cross j is k, and j cross k is I, and k cross I is j cap, right? So here we have j cap cross I cap, and when we reverse these two vectors, then there will be a negative sign over here, that is, here we have minus k cap, right? So now this vector becomes b1 minus b k cap plus c1 j cap. So now we have vector a cross I cap is equal to this vector, and we have to find the magnitude of a cross I cap, which is equal to the magnitude of b1 k cap plus c1 j cap, which is equal to the square root of minus b1 square plus c1 square, and that is equal to square root of b1 square plus c1 square, right? And therefore the magnitude of a cross I cap square is equal to b1 square plus c1 square, right? So the value of this term now is equal to vector a cross I cap square, because this quantity is equal to this one, and this one is equal to b1 square plus c1 square. So here we have b1 square plus c1 square, right? So viewers, the value of this term is b1 square plus c1 square. Now proceeding in the same manner, we can find out the values of this term and this term. See, when we have a vector a cross I cap, then here we have the sum of the squares of these two components, right? When we here we have I cap, then we have the components along j cap and k cap. So here we have b1 square plus c1 square. So similarly, if we follow the same steps, then we'll find that vector a cross j cap square is equal to, because here we have j cap, so we have to consider only I cap and k cap, right? So here we'll have a1 square plus c1 square, right? Because when we have vector a cross I cap, then we have the sum of the squares of the components except the component along I cap. So here we have j cap, so we'll leave j cap and we'll take I cap and k cap. So we have a1 square plus c1 square. Similarly, here we have vector a cross k cap square, and see, here we have k cap, so we have to leave here k cap, and we'll take these components along I cap and j cap. So we have here a1 square plus b1 square, right? So now to find the value of this expression, we'll add this term, then this term, and this term, right? So therefore the value of this expression is equal to b1 square plus c1 square plus a1 square plus c1 square, and then plus a1 square plus b1 square, right? Now if we add the terms, then we have 2 times of a1 square plus b1 square plus c1 square, right? And if we look at this vector A, then we see that the magnitude of vector A is equal to square root of A1 square plus B1 square plus C1 square, right? So here we have A1 square plus B1 square plus C1 square, so we can write it as 2 times of the square of the magnitude of vector A, right? Because if we take square of both sides, then we have the square of the magnitude is equal to A1 square plus B1 square plus C1 square, right? So we have 2 times of the square of the magnitude of vector A. So this is the value of this expression.